Hello and welcome to the Pygame particles tutorial. In this tutorial, I'll be going over how to create what you see on the screen currently, a particle system capable of over 20,000 particles at an FPS of at least 60. Let's get started. So what we have for starters is a basic boilerplate of a Pygame application. In here we have a game class that is basically just creating a screen and running a while loop that will produce a black screen. When I run this, it will just currently produce a big black screen. So in order to add particles to this, what we're gonna do is we're gonna go ahead and add a particle manager. This particle manager is going to have an init method and a list of particles. Particle manager will also have a update function. That's going to take our delta time, and we'll fill this in a little later. We're also going to have an add function. Which is going to take a list of particles. And what that's going to do is it's going to extend our particles list. All that does is takes our current particles list and extend it by appending the elements in the list we passed in onto the end. We're also going to have a draw function, which is going to take a surface. We'll finish this later. And it's also going to have a dunder length method. And what this will do is we'll return the length of our particles list. In our game function, we have to create a particle manager. So self.particle manager is equal to particle manager. Currently, there's nothing happening in the update function, but what we need to do is we need to call this particle manager.update. We just have to add one more function in the draw method. Self.particleManager.draw. And we're going to pass the surface that we're drawing to, which is our screen. What we need now is something to go inside of our particles list, namely a particle. In order to create our particles, we're going to create a particle class. The particle class is going to have an init method, which is going to take a position, a velocity, a size, and a color. And that particle's going to save the position as a vector2. It's going to save its velocity also as a vector2. It's going to save its size. And it's going to save its color. The particle is also going to have an update function, which is going to take delta time as well. And all the update function is going to do is update its position based on its velocity. So self.position plus equals self.velocity times delta time. One of the tricks that we're going to use here is adding an update image function. And to do this, what we need to do is we need to create a hash of images So in order to save this image, what we're going to do is we're going to look up our size and our color as a tuple. And if it's not in the cache, we're going to create it. And if it is in the cache, we're just going to set our image to that cached image. And to do this, we're going to use the walrus operator, which is going to assign the result of our cache lookup to that cached image variable. And it's also going to check the if statement against it all in one line instead of having to set it as equal to cached image is equal to this. If not cached image, you just do it all in one line. It's a little quicker. And if that cached image does not exist, we're going to create one. And that surface is going to be self.size by self.size. We're also going to take that cached image and fill the color into it as well. I realize now that the cached images, it needs to be cached images because there's multiple of them. We're going to set the value of our lookup equal to the image that we just created. And then finally, we're going to set our particles image equal to the cached image that we just created. When we create a particle, we have to call this function to initialize its image variable. And in the update function, we're going to return a 1. You could also return true here if you'd prefer, but basically what this 1 is going to do is it's going to allow our particle manager to realize whether or not this particle is still a valid or a live particle. Now what we need to do is update our particle manager so that when it updates, we call the update function of our particle. And to do this, what we're going to do is we're going to simultaneously create a new list of active particles for the particle manager to handle. So what this is going to be is a list comprehension. So self.particles is equal to a list of particles for each particle in self.particles if that particle returns true from its update function. So like we said before, we have this one value being returned when we call its update. So this particle will only get added to this new list of particles if the update returns 1. So if we wanted to end a particle or kill it, you would return 0 here instead. We'll get to that in just a second. Now we need to update our draw function. So our draw function is going to blit each of the particles that's in the particle manager to the surface. And to do this, we're going to use the blitz function. Now the blitz function takes in a list or a iterator of images and positions, or surfaces and positions, to draw onto the screen. And what we're going to do is we're going to use another list comprehension here, and we're going to have it store a tuple of particle.image and particle, if I could spell, dot position. And that is going to come from each particle in self.particles. Now what we're going to do is we're going to add some actual particles to our particle manager. So self.particleManager.add, and we're going to add this. Remember, it takes a list and extends the list that it currently has. So we're going to create another list comprehension of particles, right? And those particles are going to take a position, a velocity, a size, and a color. And in order to do that, we're going to go ahead and import random. So we're going to take some random numbers here. So our particle, we're going to take a position, which is going to be random.randInt, and that's going to be between 0 and our screen size .x, and the y coordinate is going to be also a random integer between 0 and screen size.y. Now we need our velocity. So what is our velocity going to be? It's also going to be an x and a y, and those are going to be random.uniform. So random.uniform is going to return a float value between some number and another number. So let's go ahead and say -10 to 10. And our y value is going to be the exact same thing. So we'll take that, pass that in. Now our size is going to be, let's say, a random number between 0 and 5. And finally, our color is going to be a random choice. And that's going to pass a list of, let's say, dark blue, blue, and light blue. And so what that's going to do is it's going to create the list, but we need to do it for some number of things. So 4 underscore in range 10. That way, we're going to create 10 particles that are randomly distributed across the screen, traveling at random sizes between 1 and 5, and a random direction, -10 to 10. Let's see what that looks like. So now we have our random particles. They're on the screen, and we're adding 10 per frame. And you can see our frame rate is continually dropping here. And that's just going to keep dropping because we keep adding new particles every single frame. Let's go ahead and add to our display caption the number of particles. And to do this, we're going to check our length value of our particle manager. And let's run that again. Now we can see that we have upwards of 10,000 particles moving randomly, and we're still at well over 100 frames per second. Now let's see how many particles that we can add until we get lower than 60 frames per second. To do this, we'll go ahead and just add an if statement. We'll go ahead and add particles only if the FPS is above 60. Let's see what we get. So it looks like we're getting about 28,000 particles. That's the limit we've hit, maybe 29,000. But there's a problem with our code, and that's that no particles off the screen get removed, and that is essentially making it so that there's more particles that are getting updated when they don't really need to be updated. So let's go ahead and fix that now. So in our particle update function, we're going to go ahead and check if the position is less than 0, or it's off to the left of the screen. We're going to say self.position.x is equal to 0. And we're also going to say that our velocity.x multiply equals -1. So that is, we're going to, if a particle flies off to the left, we're going to change its directional velocity in the x direction. We're going to multiply it by -1, so it goes the opposite direction. And we're also going to set it so that its position is now on the left of the screen. else if its position.x is greater than our screen size, which is on the right side of our screen, its position.x is equal to screen size.x. And again, its velocity will be multiplied by -1. And then we do the same thing for the y's. If it's off the top of our screen, we're going to set its position to the top of our screen. And we're going to set its velocity multiplied by -1 to make it go in the opposite direction. So if it hits the top of the screen, it's now going to come down to the bottom. And we'll do the same thing at the bottom of the screen. If it's greater than the screen size.y, we'll set its position equal to screen size.y. And once again, we will multiply it by -1 to change its y direction. Go ahead and save that. And now what we should see is that any particle that hits the wall is going to bounce off in the opposite direction. And all the particles will remain on the screen. They won't have any particles that are off the screen. And now we can see that we're getting 10,000 less particles. And this is because all of those particles that were off the screen were getting updated, but when they got drawn, they were off the screen, so it didn't actually have to draw anything because it knows what's off the screen and what's on the screen. So we get substantially less particles, but we have them all on the screen at the same time. Let's go one step further. In our draw function in the particle manager, we're using a blitz command. Now the blitz command is part of Pygame, but there's a faster version in the Pygame Community Edition called fblitz. So let's go ahead and just add that one character, takes the exact same parameters, and let's see what we get now. And we just got an additional 3,000 particles for adding a single character to our command call. I would highly recommend upgrading to pygame-ce if you haven't already. It's as simple as pip install pygame-ce. What if we want this to act like maybe a rain simulator or something like that? Right now we have essentially what I showed you at the very beginning, but with a couple different colors. So let's go ahead and make this turn into a rain simulator. So in order to do that, we're going to create our image in such a way that it's maybe each surface is 3 times as tall as it is wide. And we're also going to change it so that its screen position is created off the screen to the top of the screen, so -10. And we're also going to change its velocity in the x direction to 0, and the y direction, let's do 100. Why not? And the size, maybe reduce this a tad, change this to dark blue, so we get twice as many dark blues as we do blues. And let's see what this looks like. So now we have the particles coming down from the top of the screen as if it were raining. Oh, I say now they're still bouncing off the bottom. But what we can do is go into our update function of our particle, and if our position.y is less than 0, we're actually just going to go ahead and do nothing. We're just going to return 1 here, because that is fine. But if our position is off the screen on the bottom, we're going to go ahead and return 0, because we don't actually want to keep those particles any longer. And what that's going to do is it's going to tell our particle manager that particle.update returned to 0, and therefore we're not going to add that particle to the new list of particles as we update. And so what this should do is we should get particles that come from the top of the screen down to the bottom of the screen, and once they hit to the bottom, they just roll off the screen. Now you have a nice little rain system. Of course, it's a little slow, so let's go ahead and add a little bit of speed to that. And now it's looking a little bit better. So now you have a simple particle rain system that you can tweak with over 5,000, 4,000 particles running at well over 200 frames per second. And now you just overlay this on top of your game. Maybe you make it a background. Maybe you change the X velocity so that it's, flying off the screen to the left or the right, like it's a high wind situation. There's a lot you can do with this system, and it allows you to create so many particles at a good FPS. I would highly recommend, again, using pygame-ce for better performance. That's it for this video. Thanks for watching.